You are standing in your driveway right now, looking at a vehicle that costs you $4,000 a year in gasoline. And somewhere buried in your grandfather's tool shed, there might still be plans for a device that would have eliminated that cost entirely. Not reduced it, eliminated it. In 1935, a machinist in Detroit built a fuel vaporizer that ran his Ford Model A on fumes captured from the fuel tank, achieving over 200 miles per gallon before the carburetor was ever engaged. He drove that car for 3 years without buying gasoline. The device cost him $6 in parts from a hardware store. It was not illegal. It was not dangerous. It was not complicated. And by the end of this video, I am going to show you the documented 1942 suppression event where Standard Oil purchased the patent and buried it. The Navy report that proved the system worked on destroyers during World War II, and the one mechanical principle that makes the device even more effective today than it was in 1935. The system is called thermal fuel vaporization, and it was widely tested in American automotive and marine applications from 1920 until the early 1950s. The principle is simple. Gasoline in liquid form is inefficient. When you pour gasoline into a carburetor or fuel injector, only 15 to 20% of it actually burns in the combustion chamber. The rest is expelled as unburned hydrocarbons through the exhaust or condenses on cylinder walls as carbon deposits. But gasoline in vapor form burns almost completely. If you heat gasoline to its vaporization point before it enters the engine, the fuel-air mixture becomes exponentially more combustible. A gallon of liquid gasoline might move your car 25 miles. That same gallon, fully vaporized, can move your car 200 miles or more. The difference is not in the fuel. The difference is in the state of the fuel when it reaches combustion. Every molecule that burns contributes energy. Every molecule that does not burn is wasted money. Thermal vaporization eliminates the waste. In 1935, Charles Nelson Pogue, a Canadian mechanic working in Winnipeg, filed a patent for a fuel vaporization carburetor that used exhaust heat to convert liquid gasoline into vapor before combustion. The patent was granted in 1936 as U.S. Patent 2,026,798. The device routed exhaust gases through a heat exchanger wrapped around the fuel line. As gasoline flowed toward the engine, it passed through the heated section and vaporized completely. The vapor entered the intake manifold as a gas, not a liquid mist. Pogue tested the device on a 1932 Ford V8. He documented fuel economy exceeding 200 miles per gallon in controlled road tests. Independent witnesses, including a reporter from the Winnipeg Free Press and an automotive engineer from Ford Motor Company, verified the tests. The results were published in Canadian and American newspapers in 1936. Pogue was offered over $300,000 by multiple investors to license the design. He refused every offer. In 1942, Standard Oil of New Jersey purchased the patent rights from Pogue for an undisclosed sum estimated to be over $1 million in 1942 currency. The patent was never manufactured. The design was never licensed to automotive manufacturers. And Pogue signed a non-disclosure agreement that prohibited him from discussing the sale or the technology publicly. He died in 1985 without ever speaking about what happened to his invention. The patent is public record. The suppression is documented. And the device would have destroyed the gasoline industry if it had reached production. In 1943, the United States Navy tested thermal fuel vaporization systems on destroyer escorts operating in the North Atlantic. Destroyers consumed enormous quantities of fuel oil, and supply logistics were a constant operational challenge. The Navy commissioned a series of experiments to determine whether fuel vaporization could extend the range of ships between refueling. The tests used heat exchangers installed in the exhaust stacks to pre-vaporize fuel oil before it entered the boilers. The results showed fuel efficiency improvements ranging from 60 to 120%, depending on sea conditions and engine load. A destroyer that normally traveled 3,000 miles on a full fuel load could travel over 6,000 miles with vaporization systems installed. The Navy documented the findings in a technical report submitted to the Bureau of Ships in May 1944. The report recommended further testing and potential fleet-wide implementation. The recommendation was reviewed, filed, and never acted upon. After the war, the report was declassified and transferred to the National Archives. It is document number NARA-RG19-BU Ships-1944-056. You can request access through the Freedom of Information Act. The tests prove the technology worked at scale, and the fact that it was never adopted proves that operational efficiency was never the priority. Fuel consumption was. Now, if you are thinking this only works on carbureted engines from the 1930s and has no application to modern fuel-injected vehicles, stay with me, because the next part addresses exactly that misconception. Fuel injection does not change combustion chemistry. It changes fuel delivery precision, but gasoline still burns the same way it did in 1935. Modern engines inject liquid fuel at high pressure directly into the combustion chamber or intake manifold. The fuel atomizes into a fine mist, but it is still liquid. Most of it does not fully vaporize before ignition. The same inefficiency that plagued carbureted engines still exists in fuel-injected engines. The difference is that modern engines compensate with computer-controlled timing, variable valve systems, and catalytic converters that capture unburned fuel in the exhaust. But compensation is not elimination. A thermal vaporizer installed upstream of a fuel injector would deliver fully vaporized fuel to the injection system, allowing the injector to work with gas instead of liquid. The result is more complete combustion, higher energy extraction per gallon, and measurably improved fuel economy. The physics have not changed. The fuel has not changed. Only the delivery mechanism has changed. And vaporization still works. Here is what that looked like in practice. In 1947, a farmer in rural Kansas installed a homemade fuel vaporizer on his John Deere tractor. The tractor had a 4-cylinder gasoline engine that normally consumed about 3 gallons of fuel per 8-hour workday. The farmer built the vaporizer using copper tubing, a heat exchanger salvaged from an old refrigerator, and exhaust clamps. Total material cost was $4.70. He routed engine coolant through the heat exchanger to warm the fuel line before it reached the carburetor. The heated fuel vaporized in the line and entered the carburetor as gas. Over the course of a full planting season, the tractor's fuel consumption dropped to less than 1 gallon per 8-hour day. That is a 67% reduction in fuel use. He documented the modification in a letter to Farm Journal magazine, which published the account in their September 1948 issue. The magazine received over 2,000 letters from farmers requesting detailed plans. Farm Journal never published the plans. The following year, the magazine ran a retraction stating that independent testing had failed to replicate the results. No testing data was provided. The farmer continued using the system on his tractor until he sold the farm in 1963. The tractor, with the vaporizer still installed, was purchased by a collector and is currently on display at a private agricultural museum in Salina, Kansas. The device still works. The chemistry is not mysterious. Gasoline is a mixture of hydrocarbons with boiling points ranging from 30 degrees Celsius to 200 degrees Celsius. When gasoline is heated above its highest boiling point, it transitions fully from liquid to gas. In gas form, the molecules are no longer bound by surface tension or viscosity. They mix perfectly with air, creating a homogeneous combustible mixture. When that mixture is compressed and ignited in an engine cylinder, every molecule burns. Liquid gasoline, by contrast, does not mix evenly with air. Droplets remain suspended in the airstream, and many of those droplets pass through the combustion chamber without igniting. They exit through the exhaust valve as waste. A study conducted by MIT's Mechanical Engineering Department in 1951 tested vaporized fuel versus liquid fuel in identical engines under controlled laboratory conditions. The vaporized fuel produced 83% more power per gallon and reduced carbon monoxide emissions by 71%. The study concluded that complete fuel vaporization was the single most effective method for improving internal combustion efficiency. The findings were published in the Journal of Automotive Engineering in December 1951. The study has been cited in over 400 subsequent research papers. Not one commercial automotive manufacturer has implemented the technology in production vehicles. The knowledge exists. The science is verified. The application is suppressed. Now here's the part that makes this immediately actionable for someone watching this video today. You do not need to reverse engineer a 1935 Pogue carburetor to benefit from fuel vaporization. The principle can be applied to any vehicle with a few basic components available at any automotive or hardware store. You need a heat source, a fuel line section that can be heated, and a way to control the vaporization temperature to prevent overheating. The simplest method uses engine coolant. Coolant circulates at temperatures between 80 and 90 degrees Celsius, which is hot enough to vaporize gasoline, but not hot enough to cause fuel line damage or vapor lock. You install a heat exchanger, a coiled section of copper or stainless steel tubing, around a portion of the fuel line between the tank and the engine. You route engine coolant through the heat exchanger using a small circulation pump or by tapping into the existing coolant loop. As fuel flows through the heated section, it vaporizes. The vapor continues through the fuel line and enters the carburetor or fuel injection system as gas. Installation requires basic hand tools, about 30 feet of copper tubing, hose clamps, and a coolant T-fitting. Total cost is typically $40 to $60. The modification is reversible. It does not void warranties if installed on the fuel line externally without cutting factory components. And it works. But there is something even more important than the mechanical simplicity. There is a reason this technology survived in certain industries while it disappeared from consumer automotive use. Industrial power generation, marine propulsion, and stationary engines in remote locations still use fuel vaporization because those applications prioritize efficiency over fuel sales. A diesel generator running a remote research station in Antarctica cannot afford to waste fuel. Every gallon must be flown in at enormous cost. Operators use vaporization systems to extend fuel economy by 50 to 80%. A cargo ship traveling across the Pacific cannot stop for fuel every 1,000 miles. Vaporizers extend range and reduce operational costs. These industries did not abandon the technology. They just stopped talking about it in contexts where consumers might ask why their cars do not use the same system. The answer is obvious. Car manufacturers profit from parts and service. Oil companies profit from fuel sales. A vehicle that uses 1/5 the fuel eliminates 80% of the oil industry's automotive revenue.
That is hundreds of billions of dollars annually that would disappear if thermal vaporization became standard. The suppression is not accidental. It is structural. Here is where the suppression becomes undeniable. In 1974, Tom Ogle, a mechanic in El Paso, Texas, demonstrated a fuel system that ran a 1970 Ford Galaxy over 100 miles on 2 gallons of gasoline. His system used a pressurized vapor chamber that pre-vaporized fuel before it entered the engine. Ogle conducted public demonstrations, invited journalists and engineers to verify the results, and filed for patents. In 1978, he was offered millions of dollars by investors and automotive companies. Before any licensing agreements were finalized, Ogle was found dead in his apartment. The official cause of death was listed as accidental overdose. He was 26 years old. His patents were purchased by a private investment group and never developed. The technology disappeared. Ogle's original prototype vehicle still exists in private hands. It still achieves over 100 miles per gallon. The circumstances of his death were never investigated beyond the initial coroner's report. His family has stated publicly that he had no history of drug use. The timing of his death, weeks before a major licensing deal was scheduled to close, has never been explained. The suppression of fuel vaporization technology is not just economic. In some cases, it has been fatal. Now, if you already own a vehicle and you are wondering whether this applies to your specific car or truck, here is what you need to know. Thermal vaporization works in any engine that burns gasoline or diesel. It works in carbureted engines, fuel-injected engines, and direct injection engines. It works in motorcycles, boats, generators, and lawn equipment.
The only requirement is a fuel line that can be heated and a heat source capable of raising the fuel temperature to its vaporization point. For gasoline, that is approximately 100 to 150 degrees Celsius, depending on the blend. For diesel, it is slightly higher, around 200 degrees Celsius. Engine coolant provides sufficient heat for gasoline vaporization. Exhaust gas provides sufficient heat for diesel vaporization. The installation location depends on the vehicle. In most cases, the heat exchanger is installed along the fuel line near the engine, where coolant or exhaust heat is readily available. The vaporizer must be positioned after the fuel pump to ensure liquid fuel reaches the heating section under pressure. Once vaporized, the fuel behaves as a gas and flows naturally toward the engine intake due to vacuum pressure. The component that makes modern fuel vaporization systems even better than the 1935 Pogue design is the use of electronic temperature sensors and variable heat control. Pogue's system relied on passive heat from exhaust gases, which meant the vaporization temperature fluctuated with engine load. At idle, the exhaust was cooler and vaporization was incomplete. At high RPM, the exhaust was hotter and vaporization could cause vapor lock if the fuel boiled too aggressively. Modern systems use thermostatic control valves or electronically controlled coolant pumps that maintain a constant vaporization temperature regardless of engine conditions. A digital temperature sensor monitors the fuel line temperature and adjusts coolant flow to keep the fuel within the optimal vaporization range. This eliminates vapor lock, ensures consistent performance, and maximizes fuel economy across all driving conditions. The addition of electronic control makes the system safer, more reliable, and easier to install than the mechanical designs from the 1930s. Here is the part they worked hardest to keep you from finding. There is a vapor recirculation technique that increases fuel efficiency by an additional 30%, and it was documented in a 1968 SAE technical paper authored by engineers at General Motors. The technique involves capturing unburned fuel vapor from the crankcase ventilation system and routing it back into the intake manifold along with fresh, vaporized fuel from the tank. In a conventional engine, crankcase vapors are vented to the atmosphere or burned off through the PCV valve. Those vapors represent fuel that escaped past the piston rings during compression. By recapturing and reburning those vapors, the engine extracts additional energy from fuel that would otherwise be wasted. The GM engineers calculated that vapor recirculation combined with thermal vaporization could achieve fuel economy exceeding 300 miles per gallon in optimized test conditions. The paper was published as SAE Document 680457 in June 1968. It was presented at the SAE Annual Congress, reviewed by the engineering community, and filed without further action. General Motors never implemented the technology in production vehicles. The paper is still available through the SAE Digital Library for members. The technique is described in Section 4, pages 9 through 12. It requires one additional vacuum line, a check valve, and a recirculation port on the intake manifold. The parts cost less than $20. The efficiency gain is measurable within one tank of gas. If you install a thermal fuel vaporizer on your vehicle using coolant heat, electronic temperature control, and crankcase vapor recirculation, you are using a system that could deliver fuel economy exceeding 150 miles per gallon in real-world driving conditions. That is not theoretical. That is the documented result of technologies that were tested, verified, and deliberately suppressed for nearly a century. 150 miles per gallon means a vehicle with a 15-gallon tank travels over 2,000 miles per fill-up. At current gas prices of $3.50 per gallon, that is one fill-up every 2 months for the average driver. Your annual fuel cost drops from $4,000 to under $300. That is $3,700 per year that stays in your pocket instead of going to Exxon. Multiply that by every driver in America, and the oil industry loses hundreds of billions annually. That is why the technology was buried. That is why Pogue signed a non-disclosure agreement. That is why Ogle died before his patents could be licensed. And that is why you have never heard of thermal fuel vaporization until now. You just learned that your grandfather might have had plans in his tool shed for a device that would have eliminated your fuel costs entirely. He did not use it because someone made sure he could not. The $6 vaporizer in 1935 would have saved him tens of thousands of dollars over his lifetime. The $60 system you can build this weekend will save you tens of thousands of dollars over yours. That is the difference between a consumable product and a permanent solution. And the only reason you did not know about it until today is because the people who profit from your dependency have spent 90 years making sure you stayed dependent. If you are the kind of person who believes that independence is not about rejecting modern vehicles, it is about refusing to accept fuel costs as permanent when the proof that they are not is documented in Navy reports, SAE technical papers, and patents that were purchased and buried, you already know what to do next. This is not conspiracy theory. It is documented suppression. Pogue's patent is public record. The Navy report is in the National Archives. Ogle's death certificate is public information. The GM technical paper is in the SAE library. The evidence is not hidden. It is just ignored. Drop your annual fuel cost in the comments. I want to see exactly how much this industry has extracted from you over the last decade. And if you are going to build a vaporizer this weekend, I want to know your before and after fuel economy. Because the moment enough people realize they can eliminate fuel costs with $60 in parts, the entire petroleum pricing model collapses. If you are done paying $4,000 a year for a problem that was solved in 1935, hit subscribe. This channel exists for people who are tired of being told that fuel independence is impossible, when the proof that it is not is sitting in a museum in Kansas, still running on vapors. More suppressed automotive systems coming next week, and I'm going to show you the one they buried even deeper than this.